In this video, I would like to extend on what I covered in my last video, which was applying the product rule for the derivative of a function that could be written as the product of two functions. In this case, we now have the product of three functions. So we're looking to take the derivative of a function y, where y can be written as f of x times g of x times h of x. So we have our f of x is the x squared, our g of x is the sine of x, and our h of x is the cosine of x. Now, there's a formula that I could write and say memorize this, but I think it's I think it's easier to just look at it from a conceptual standpoint. So what the product rule says, and so this is not specific to the product of three things or two things. This is the product rule for any number of things multiplied together, any number of products, or any number of factors in a product. We take the derivative one factor at a time. So what I mean by that is, first, if we're looking at y prime, first we could take the derivative of the f function, leave the other two alone. So f prime times g times h. Then we could take the derivative of the second function, f times g prime times h, and then we could take the derivative of the third function in the product. Leave the f, leave the g, and take the derivative of the h. So each term contains one derivative and two functions. All right, and that's the formula for the, specifically this is the formula for the derivative of product of three factors. But we could take this method and use it in any string of any length of products. Okay, so for the specific problem, y prime is equal to, we'll take the derivative of the first. Let me stick with the color coding. The derivative of the first, which is 2x, times the sine of x times the cosine of x. Okay, then we'll take the derivative of the second. So leave the x squared. The derivative of sine is cosine. And then there's another cosine at the end. Let's make this a little bit smaller so I have some room. And then finally, we'll leave the first one, x squared. We'll leave the second one, the sine of x. And the derivative of cosine is negative sine. So we'll have a negative sine of x. Okay, so let's do some simplifying here. One, we have a double angle formula here, so we could condense this if you want. So we'll recall this from trig. 2 times the sine of x times the cosine of x is equal to the sine of 2x. Okay, so that first term condenses to, well, we'll leave the x alone, but the 2 and the sine x cosine x becomes the sine of 2x, so we'll have x times the sine of 2x. Okay, next. Looks like we've got x squared times the cosine squared of x. Cosine times cosine. And then we'll have a minus x squared times the sine squared of x. Now we could factor out this common x squared from the last two terms, and then it looks like we have another double angle formula. So we have an x sine of 2x plus, now if we factor out the x squared, we'll have cosine squared of x minus the sine squared of x, and our double angle formula for cosine. Cosine squared minus sine squared of x is equal to cosine of 2x. So we apply the double angle formula for sine, double angle formulas, and the double angle formula for cosine. So it looks like we could write y prime as x sine of 2x plus x squared cosine of 2x. I think that's as, if we could factor out one of the x's, but I don't think that's going to help us much. So this is about as condensed as we can get for our derivative. So definitely a little bit of algebra going from, now this is usually how it works, especially moving on as the derivative problems get a little bit more complicated once we cover some more of the derivative rules, but it's one step of calculus. That's right here. Apply a calculus formula, and the rest is all algebra. This is all the prerequisite stuff that you need to be familiar with before starting a calculus course. So again, I've said it before, calculus is very algebraically intensive. Okay, that about does it for this one.